All right, so today we are starting chapter 3, and we're going along with the textbook this time, so I'm continuing to name them the way we did the first chapter, so 3.1. Today we're talking about lines and angles, and specifically lines and angles when we have a set of parallel lines. So the first thing I want to do is, you've seen these slides before, I just want to remind us all what parallel lines are so that we have no confusion, right? Parallel lines are coplanar lines that do not intersect, right? They go forever and ever but never touch. And so you could use them with those little arrows there on the lines to show that they are parallel. There's another example of the arrows, or you can use that parallel sign there. It says line L is parallel to M, or AB is parallel to CD, right? And so again, we've gone through examples before, like hardwood floors. Those lines in the hardwood floors are parallel lines. They'd never meet, even if you continued on forever and ever. Parking lot, same thing. And we've talked about the bane of all 16-year-old existence, parallel parking, right? When you parallel park, your wheels are parallel to the curb. Okay, so those are all examples of parallel. Okay, and then streets are parallel. So for example, Calhoun and Kellogg Street right near us are parallel streets. Okay, so in our notes, first of all, we got to know the symbol of parallel. So the first symbol is just two parallel lines right there. And so you'd write it like this. You'd say that AB is parallel to CD. Right? The other way that we note it, the only way we note that lines are parallel is through those matching arrowheads. You see those, in this case, these blue arrows right there. Sometimes there'll be double arrows, sometimes triple. Again, depending on how many parallel lines you have in a drawing, you can put as many arrowheads as you want on them to show that they're parallel, right? And then the definition of parallel lines is coplanar lines that do not intersect. Right? So two lines that are in a plane, and even though lines go forever and ever and ever in both directions, parallel lines never intersect. I'll give you a couple seconds to get this down in your notes here. So you have both the symbols and the definition. All right, so again, as a review, this isn't even in your notes. I just want to talk about it very quickly. Perpendicular lines, those are lines that intersect to form a right angle, so they look like that. The notation is you read this as M is perpendicular to N, and four right angles are formed. So again, perpendicular lines, you guys seen like railroad tracks. The tracks themselves are parallel. Those cross beams are perpendicular to the tracks. Window panes, you've got horizontal ones and vertical ones. The horizontal ones and vertical ones are perpendicular. And streets, so for example, Mission Boulevard and Calhoun right near us, those meet at right angles, so those are perpendicular streets. Okay. The final one I want to talk about is skew lines, one we have not talked about yet. Okay, so when lines do not intersect, they can be either parallel, which we've talked about, or skew. So parallel lines lie in the same place and do not intersect. So for example, these little blue lines here on the board, that the writing lines, those are all parallel, and they're all in the same plane. The plane is the whiteboard we're looking at right now. So those are examples of all parallel lines. Okay, skew lines are lines that do not intersect and lie in different planes. So for example, if we had that blue line on the screen and then like some line coming from where you are to on the screen, those two lines wouldn't intersect, but they wouldn't be parallel because they're on different planes. And then finally, when we talk about parallel, we talk, segments and rays are parallel or skew if the lines to which they're made of are parallel and skew. So we talk about lines, but we're saying the same thing about rays and line segments. Okay. So let me give you an example of some skews, or you guys give me some examples of some skews. I drew over here these different boxes here, and so let's name some segments that are parallel to GH. So who can tell me a segment that's parallel to GH here? Which one? DC is a great example. DC is parallel to GH. What else you got? AB is parallel to GH. I agree. They're going to be in the same plane this way. Yeah, that would be one. IJ is another example of ones that are parallel to GH. Okay. Now let's look at AB right here. AB. What are some lines that are skew to AB? So don't touch AB and are in a totally different plane. So, for example, well, JI I think is actually parallel to AB because if you you drew this different plane like here, it would be parallel. So that's one idea. What else we got? Okay, well, I heard a couple ones. I heard N. Which one? Oh, ND. Okay, ND is an example of one that would be skew, right? ND goes like this, and it's like this, right? They don't ever touch, and they're in different planes. I think one that's really easy to see, for example, would be DG. Right? DG and AB never touch. They're in different planes. Right? So even though, so AB and DG, if you look at them, DG is going to like sort of become in front of it from our perspective because AB is sort of behind. So DG is in front. So DG is going to be like this, and AB is going to be like that. So you're never actually going to, they're never going to touch, but they're not parallel because they're in different planes. So that's what skew is. Okay. So exactly what is skew? Skew are non-coplanar lines. So again, they're not in the same plane, and they are not parallel, and they do not intersect. So those are skew lines. Non-coplanar lines, they're not parallel, and they do not intersect. So let me give you a minute to write that down. And just as lines can be parallel, that they go on forever and ever and ever and never intersect, planes can be parallel as well. So for example, remember a plane has infinite length and width but no depth. So in the diagram to the right here, we need to name two parallel planes. So two planes that even if they go on forever and ever are not going to intersect. Anyone have any thoughts on that one? What are two planes in this figure that are parallel, never going to intersect? Okay, well, remember planes have three letters. So I think ABG, that one at the top, and CDI, right? That's on the bottom. Like, so imagine this thing. This is like a box, right? So we got the top of the box and the bottom of the box. Those are planes that are parallel. So plane ABG and plane DCI. Okay? Then we got the plane on the left. That would be ADG, and the plane on the far right, that would be BCH. Those two also are parallel. They would never touch. And the final one is the one on the very back, from our perspective. That would be GHI. And the one at the very front, that would be ABC. Those are planes that never touch. Okay. And lines can be parallel to planes too. So question B is asking us, find a line that's parallel to GHIJ. So GHIJ is that one in the back there. And so for example, line AB is a line that if you extend that plane in the back, GHIJ, forever and ever and ever, and you extend AB forever and ever and ever, they're never going to touch. They are parallel. Right. In fact, any line in that front plane that's parallel, so AB or AD or AC or BC, any of those lines are going to be parallel to that plane in back, GHIJ. Okay, so in the diagram to the right, name three pairs of parallel planes. So everybody think about that for a second. Okay. So we've got the one on the top and the one on the bottom. So the one on the top would be QRS, and the one on the bottom would be VWU. Okay, we got the left and the right. So on the left we have PST, and on the right we have QVU. And we've got on the front and the back. On the back we've got QSW, and on the front we've got RPT. Okay. Any questions about parallel planes? How I'm naming planes? How we see? You got to get used to. Again, this is this three-dimensional figure shown in two dimensions. So you got to be able to see it, so it sort of pops out to you. You can see, what's front, what's right, what's left. So any questions on that? Now's a great time to ask. If you're sort of confused of what I was doing when I was saying front and back, if you didn't see it, now's the right time. Any questions? All right, let's go to our notes and write down definition of parallel planes, which are simply planes that do not intersect. Planes that do not intersect are parallel planes. All right, so once you have that definition out in your notes, try the first example problem. It's just asking you to some questions about parallel skew lines and planes. So do that. I'll show you that in a second. If you haven't printed out notes, I'll show you that so you can do it in a second as soon as everybody gets these down. Okay, 15 more seconds to get your notes and I'll show you the example problem. Five more seconds. All right. So everybody work on this example problem. You should be able to answer all 6 of these questions. Oh, it's also asking you to draw arrows on there, so if you have the thing out, draw the arrows on. If you don't, make sure you know which ones, how you would draw the arrows, and we'll go through this one in just a minute here. Sorry. Yeah, do all. Oh, good question. It's sometimes asking name 2 lines that are skewed. Just pick 2 lines. You don't have to pick every single pair of skew lines available. I'm sorry. I'm not sure what you're asking. I'm sorry. Yeah, so you just pick a line. Just pick one. So you may be different than the one I chose. That's fine, as long as it's the right answer. It's fine. Okay, I'm gonna give you about 90 seconds. Oh, thank you. What is this? All right, 30 more seconds to answer all 6 of these questions. I see most of us working on it. Some of us are not. This is the kind of thing you need to be working on so that by the end of the chapter, you're not stuck, right? This is sort of the foundations we're building everything on. So if you don't know what these things are, you're going to get stuck all chapter. So this is the ones to try out. Make sure you know how to do these. Okay, so in plane A, B, first of all, it's asking us to use the arrows to show that, for example, that AE is parallel to BF. So I put those lines like that. Okay, you can see them right there. I'll do it again. Oops, right. So you see right there. Okay, and also the fact that AD is parallel to BC. So like that. So you can see that they're different, right? I put one set of arrows for one, 2 sets of arrows for the other, so you can see, just glancing at it, what is parallel to what, because of the different arrows. All right, so in plane ABCD, that's that yellow plane at the top. What line is parallel to AD? So in that plane, which line is parallel to AD? And the answer is going to be what? BC. You guys got it. Excellent. Oh, sorry, notice measure. Okay, BC. Okay, in plane ADHE, ADHE. So that's the one over on the left. What line is parallel to AD? EH, right? Or HE, right? On this plane on the left, which one is parallel to AD? That would be the one on the bottom here, EH. I call it HE, same thing. All right, in the plane ADFG, so ADFG, that's a weird one, right? ADFG sort of splits our box in half that way. What line is parallel to AD? And the answer would be FG. Right. Okay, now this one we're all going to have different answers. It's my name two lines that are skew. So who had an answer for that one? Emily, do you have one for that? Two lines that are skew. Okay, you said AE and CD. Look at those. Those are not in the same plane, and they would never touch. That's perfect. That's a great choice of skew lines. Excellent. Okay, Matthew, you got one for me? AE and CG are actually going to be parallel. Right? If I took this box and cut it in half that way, they'd be on the same plane. So that one is not it. Lana, do you have one you were going to share with us? Okay, you had one that's parallel? Okay, so give me one AE and what? AE and, okay, AE and GH is a good one, or AE and GF, or AE and CD, or GC, or GD, or AE and GB. These are all examples of ones that would be skew lines. So what did I wrote as an example? I just picked CB and DH. CB and DH are skew lines, but again, there are lots of examples you could have chosen. Okay, name two planes that are parallel. And so the ones I chose, again, there are different options. There are three different choices you could choose. I chose the yellow one at the top, plane ABC, and the one on the bottom, EFG. Of course, you could have chosen the one on the left and the one on the right, or the one in the back and the one in the front. But since these were yellow, it was easier to see. I'm sorry, say again? AE, ADC, yep, is the top one. EHG is the bottom one, yep. So again, you can pick any three letters of the four you want. So any three letters of A, B, C, D, I chose ABC, you chose different ones, that's fine. And any four letters of the bottom one, I chose E, F, G, you chose different ones, but again, that's totally fine. All right. And then finally, what two segments are parallel to plane A, B, C, D? So you want ones that are parallel to that top plane there. And so we got EF, FG, GH, GE, essentially pick any 2 points from that bottom plane there, and they'll make a line that is parallel. EH, FG, yep, those are both, again, any two points you want of EF, GH, pick any two, and those will make a line that is parallel to that top plane. All right, so quick review. We've gone through parallel lines, we've gone through skew lines, which are different. Both of those don't touch, and we've talked about parallel planes and lines. Any questions on all that stuff? This all makes sense? Excellent. Okay, we're going to move on to sort of our next topic here, which is about the transversal. What is a transversal? Okay, a transversal is a line that intersects two. I say parallel lines. That's actually not true. It's just it's a line that intersects two lines at different points, except that we always do parallel lines. So a transversal is a line that intersects two lines at different points, but when we talk about it, it will almost always be parallel. All right. So here is an illustration for you. I've got two lines. These lines are parallel here. And so there are parallel lines and a line that intersects at 2 points. Okay, so there is a transversal, right? That line T is a transversal. And when you do that, you form 8 different angles. So there's a transversal with parallel lines, and you'll notice that every time I do that, I'm forming 8 angles. So let's talk about on our notes what a transversal is. Okay, a transversal is a line that intersects 2 or more coplanar lines at distinct points. So again, you'll notice I took the word parallel out because that's really not the definition, although that's what we're going to do pretty much exclusively. So it's a line that intersects two or more coplanar lines at distinct points. So line T there is a transversal of line L and line M. Now, when we do this, there are two different areas in this I want to talk about. The first is what's called the exterior. Okay? The exterior is the part that is not in between those lines. And so we would say that in this example, angle 1, angle 2, angle 7, and angle 8 are all exterior angles. Those are all called exterior angles because they are on the exterior of those of the lines that make up the transversal. Okay? We also have an interior. And the interior angles in this particular example would be 3, 4, 5, and 6 because they are on the interior, in between the two lines that are crossed by the transversal. So a transversal is just a line that crosses two other lines at distinct points. And whenever I do that, I create 8 new angles. 4 of those angles are called exterior angles because they're on the outside of the two lines that cross the transversal. And 4 of those lines are called interior angles because they're on the interior of those two lines that cross the transversal. I still see some people writing down. Let's finish this in 15 seconds. We're going to move on to our next stuff here. All right, so today what we're going to do is we're going to learn the names of some of these angle pairs. Some of these pairs that are created when two lines are crossed by a transversal have a specific names. So today we're going to talk about the names of the angles, and then next class we're going to talk about what are the relationships. Like how do we use this? Are they supplementary? Are they congruent? Whatever they are, we got to figure it out. But for right now, we're just coming up with just the names of them. All right, so the first one we're going to go through are vertical angles. And you guys have done this before. I just added this in. It's not actually in your notes because you've done this so many times. I don't have it in your notes this time. I just want to go through it again. These are angles that are opposite from each other. So for example, 1 and 4 there are vertical angles, right? Because they are across from each other. They are opposite. Or 2 and 3 there are vertical angles. Or 5 and 6 you can see, and 7 and 6 are vertical angles. Those are just vertical angles. Again, I don't have those in your notes. I just want to remind you that that is indeed one of the relationships that exists when we cross this. All right, the next one, this is in your notes. Alternate interior angles. Okay, there's a lot of these names, and don't get freaked out by it, okay? So the first thing is it says it's interior. Great, the interior, as we know, is here. So I'm going to get rid of those other angles. And alternate just means they're on opposite sides of the transversal. That's what alternate means. So for example, in this one, 3 and 6 would be alternate interior angles, or 4 and 5 would be alternate interior angles. These are examples of alternate interior angles because they're on the interior, and alternate means opposite sides of the transversal. So 3 and 6 in this example, and 4 and 5 would be alternate interior angles. Okay, so in our notes, non-adjacent interior angles, they lie on opposite or alternate sides of the transversal. Okay, I would just draw a diagram. I think is probably the easiest thing to do. Right, alternate interior angles are on alternate sides of the transversal on the interior, as I was showing before. I don't think I have a graph here, do I? No, but I do have the example up above. Using the example we have up above, you can see that angles 4 and 6 are alternate interior, and angles 3 and 5 are alternate interior because they're both on the all those are on the interior, and 4 and 6 are on opposite sides of transversal, and 3 and 5 are on alternate sides of the transversal. Okay, so we just talked about alternate interior angles. The next one we're going to talk about is alternate exterior angles. So what is that one? Alternate exterior angles. Okay, so that means that they're on the exterior. So those are the ones that are possible. Let's get rid of these. And then alternate means opposite sides of the transversal. So in this case, it would be 2 and 7 and 1 and 8 because they're on the opposite sides. That's what alternate means, is opposite sides. And they're on the exterior of those angles. Okay, so in our notes, these are non-adjacent exterior angles. They lie on opposite or alternate sides of the transversal. And in our example up above, they would be, for example, angles 1 and 7 are alternate exterior, and 2 and 8 are alternate exterior. See people taking some good notes. Excellent. Make sure you have the diagram and you have the examples, because that's a lot. To me, just saying, oh yeah, 1 and 7 and 2 and 8 is a lot easier than trying to understand non-adjacent exterior angles that lie on opposite alternative sides of the transversal. So have the examples there. So our next one is corresponding angles. Okay, corresponding angles are two angles that occupy corresponding or the same position. So what does that mean really? Okay, so for example, when I break this up, you'll notice that I have two sets of 4 angles, right? I've got 1, 2, 3, 4 at the top and 5, 6, 7, 8 at the bottom. And those are formed by one of the parallel lines and the transversal. And you'll notice that number 1 and number 5 are in the top left of that. So those are what are called corresponding angles. 1 and 5 would be corresponding because they're in the same position. They're in the corresponding position. Similarly, 2 and 6 would be in the top right. Those would be corresponding angles. 3 and 7 are in the bottom left. Those would be corresponding angles. And 4 and 8 are in the bottom right. They'd be corresponding angles. They're in the same position, the corresponding position, so they're called corresponding angles. Okay. So in the corresponding or same position, they lie on the same side of the transversal. One's interior and one's exterior. But again, I think the easiest thing to have is the examples. So in the above example, 1 and 5 would be the upper left. 2 and 6 would be the upper right. 3 and 7 would be the lower right, and 4 and 8 would be the lower left. So those are corresponding. They're in corresponding positions. Those are corresponding angles. All right, so we've got one more angle relationship that's caused by a transversal crossing two parallel lines, and that is same side interior angles. And I would hope everybody can figure out what that is, but we're going to go through it, make sure we got it. Okay, so same side interior angles are two angles that lie in between the parallel lines on the same side of the transversal. So they're interior, so it's those. We're going to get rid of 1, 2, 7, and 8. And they're on the same side. So 3 and 5 would be examples of same side interior angles. And 4 and 6 would be examples of same side interior angles. Okay, so the interior angles that lie on the same side of the transversal, and our examples in the above example would be 4 and 5 are same side interior angles, and 3 and 6 are same side interior angles. I've been teaching geometry for a bunch of years, and I've never understood why. There must be a good reason, but they always introduce these three, and they never introduce same-side exterior angles. And I'm hoping everybody can figure out what same-side exterior angles would be. I'm not having it in our notes, so it won't be till later, but same-side exterior would be, for example, 2 and 7 are on the same side and exterior, or 1 and 8. But we're not worrying about that right now. All right. All right, so there are these other angle relationships. Okay, and they're named for where they're located. So I said like same side versus alternate side, interior versus exterior, right? So same side would be 1, 3, 5, and 7, or 2, 4, 6, and 8. Alternate side, for example, would be 2 and 5, or 3 and 8. And we've got our interior, our 4, 5, 6, 4, 5, 3, 4, 5, 6, and the exterior would be 1, 2, 7, and 8. Okay, so again, that's just how we can remember this. Okay, and our final one, which again I don't have in our notes because we have already talked about this a lot, is two angles that form a line. So for example, 1 and 2, or 6 and 8. Whoops. Okay, so 1 and 2, 6 and 8 are examples. Didn't we already do this one? Same side interior? Didn't we just do this one? Yeah, sorry, we did this one. I don't know why I have it twice. Okay, same side exterior, here they are. Okay, so those would be outside and same side, although I don't think those are in your notes. Okay, great. So here are some examples in your notes. Okay, so I want you to name all the pairs of alternate interior, alternative exterior corresponding in same side interior based on what we have over there. So see if you can do this. Name all the pairs. See some people working hard on this. Again, this is stuff you need to know how to do. Take a look up and try these. Make sure you know how to do them. We're going to go over it in 60 seconds. All right, let's take a look at A. Alternate interior angles. All right, well, the interior angles, here are my lines, M and N. So what's in between them? The interior is 2, 3, 6, and 7. So those are the interior angles, and the ones that are alternate would be opposite sides. So that would be, for example, 2 and 6 are on opposite sides and interior, and 3 and 7 are on opposite sides of the interior. Okay, let's name all the pairs where alternate exterior. So again, now the exterior is going to be the other ones. 1 and 8 and 4 and 5 are all exterior. So alternate sides would be 1 and 5, and 4 and 8 would be examples of alternate exterior. 1 and 5 are on the exterior on opposite sides, and 4 and 8 are on opposite sides of in the exterior. Okay. Name all the pairs of corresponding angles. All right, so it looks like 1 and 3 are in the upper left. Those would be corresponding. 2 and 4 are in the upper right. They'd be corresponding. 8 and 6 are in the lower left. They'd be corresponding. And 7 and 5 are in the lower right. They would be corresponding. So all these examples, 4 sets of corresponding angles. And the final one, name all the pairs of same side interior. So again, interior is going to be our 2, 3, 6, 7. And then same side would be, well, 2 and 3 are on the same side, and 6 and 7 are on the same side. So 2 and 3 and 6 and 7 are same side interior angles. Any questions? Okay, just a lot of terminology today. Not any math yet, but just a lot of terminology we have to go through.